Here's another example of a feedback circuit. In this one, the type of feedback circuit that it has the input is Vs and the output wanted is I naught. So this one is a series type network. So series. After identifying the type of network it is, I want to find the feedback portion. So I do not include RL in the feedback portion. I look at the rest to see if it biases the circuit in any way. In this case it does not, so all of this is going to be included as my feedback portion. So to find from the feedback portion, I want the three pieces of information, R11, R22, and beta feedback. So I'm going to redraw this feedback portion. And I look at where it connects back into the circuit, and that's the location for my R11 and my R22. So at this location is where it connects to the rest of it. And at this location is where it connects into the input. So this is where I'm going to locate R11. So to find R11, I have to look at the type it is. It's series, which means on this side I leave this open, and I look at the equivalent network of resistances, or again you can do impedances. So this is going to be R1 in parallel with R2 plus R quantity. So that's my R11. I redraw again the same feedback portion. And I look back at the type. It's series on this side, so looking in here, which is the same location from up here, this I just leave open. So R22 is going to be R in parallel with R1 plus R2 quantity. Now beta, again, redraw the same network. And at the location of the output, I look at what I want. I want I naught, so I'm going to redraw the current source I naught. And on the input, I want a voltage. So at the location where it connects in, I'm going to find that value for VF. So I see that I have a current divider here. If I find the current going here, I can say that VF is equal to R1. For beta, for this, I want to find VF over I naught is the quantity that I want to find. So VF is equal to the current, which is going to be I naught times the resistance in the other branch over the total. So this is my current times R1. So then I can divide by I naught and get VF over I naught is going to be my R value. So now I want to redraw this circuit for the small signal. I've been told that this has a gain of A. And it has ideal input resistance, so I'm going to assume that that's open. And also that RO is ideal with 0 ohms. So all I have here is a voltage source with value A1 times the input Vn. It goes out here. I erase all of the feedback part and replace that with R11 and R22. So on this side I have R11, which was R1 in parallel with R2 plus R. And over here I replace it with R22, which was R in parallel with R1 plus R2. This was my RL. So now that I have my new A circuit, I want three pieces of information. I want the gain A. In this case, the gain A will be I0 over Vs. I want Ri, which will include Rs. In this case, there's no Rs, and my input is infinite, so I can just leave this as infinite. Then I have my output resistance, which is going to be located here. As I look in here, I also see that this will be shorted, so my output resistance is going to be, again, ideal. So all I'm going to find from this is A. So to find A, which is going to be I0 over Vs, I need to get an equation for I0 in terms of Vs. So I0 can be written as the voltage A1 Vn all over all the resistances. And then I can write Vn in terms of Vs. With it being open, there's no current flowing through here, so Vn will be equal to Vs. And I get I0 over Vs is equal to A1 over RL plus R in parallel with R1 plus R2. So now that I have A, I can use that information to find AF, which will be A over 1 plus A beta feed. And that is going to look like this. AF is going to equal the A, which was A1, all over the summation of all of them, RL plus R in parallel with R1 plus R2, all over 1 plus A1 all over RL plus R in parallel with R1 plus R2 times beta feed, which is going to be R1 times R all over the summation of all of them, and that is my AF